Question number 2. At which of the position of the pyridine ring would the electrophile attack under vigorous conditions? That is, whether the electrophile would attack at position 3 or position 2 or position 4. To know the answer to this question, one has to compare the stability of the intermediate cations that are formed by attack of the electrophile at the third, at the second and at the fourth position. Let us first look at the intermediate cation that is formed by the attack of an electrophile at the C3 position. The intermediate cation formed is a resonance hybrid structure of 3 contributing forms. To restore neutrality, an H plus is eliminated and the electron pair that is shared with H is taken in to form 3 substituted product. The same applies for attack at C2 and attack at C4. Structure A and structure B resulting from attack of an electrophile at the C2 and the C4 position respectively are nonsensical structures. That means structure A and structure B would never even form at the very first place. Why? Because these structures are high energy structures or they are very unstable structures. The reason of this is that the nitrogen atom in these structures are unstable. The nitrogen atom in these structures have only 1, 2, 3, 4, 5, 6 electrons in its valence shell. Here too, the nitrogen atom has 6 electrons in its valence shell. If you exclude these structures and look at other structures, be it from an attack at C3, C4 or C2 positions, other structures have a nitrogen atom in which the nitrogen atom has 8 electrons in its valence shell. Look at this: 1, 2, 3, 4, 5, 6, 7, 8. If you look at other structures, all other structures have 8 electrons in its valence shell. The nitrogen has 8 electrons in its valence shell and thus the nitrogen has achieved the inert configuration of neon in these structures. That is not the case with structure A and structure B. It is for this reason that structure A and structure B have minimum contribution towards the resonance hybrid structure of the intermediate cation forms for attack at C2 and C4. Such is their contribution that their contribution is regarded as nil. That is to say that the resonance hybrid of the intermediate cation for attack at C2 is a resonance hybrid structure of these two, and the resonance hybrid structure for the intermediate cation by attack at C4 is a resonance hybrid structure of these two. On the other hand, the resonance hybrid structure is a combination of 3 resonating structures for attack at C3. Thus, the resonance hybrid structure of the intermediate cation at the C3 is more stable than at the C2 and the C4 position. Therefore, the attack at C3 position is preferable and it is the 3 substituted product that predominates. In case the third position is filled, attack would take place at the other available beta position relative to nitrogen atom, which is 5th position.